Hello, grade 7. So we are starting with a new chapter, chapter 9, called the voltage. The objectives that we're going to cover during this week's lecture is that you guys will be able to measure the electrical voltage using a voltmeter. You're going to recognize that the SI unit of voltage is the volts, and you're going to determine the voltage across a closed switch, open switch, connecting wire, battery, and a lamp. Okay, so consider this circuit that consists of a battery, a lamp, a switch, and connecting wires. Once we close the switch, the lamp glows. Okay, it's a typical circuit. All right, so what is the voltage source in this circuit? Which electrical component is giving electricity? It is the battery, right? So the battery is the voltage source in the circuit. And once it is connected to a closed circuit, the voltage in the battery will produce current flowing through the circuit, and this is why the lamp glows. Now, what do you think will happen if I removed this voltage source? What do you think will happen? So I will be closing the switch. Nothing happens. The lamp doesn't glow. All right, so for the lamp to glow, it needs to be put in a closed circuit with a voltage source, with a generator, all right, to produce, and this generator will produce electrical current flowing through the circuit, and the lamp will glow. Okay, so as we just said, when a voltage source is connected to a closed circuit, the voltage will produce current flowing through the circuit. Now, we might have different batteries with different voltages, so there must be a unit for this value, for this voltage of a battery. Yes, there is, three actually: kilovolt, volt, and millivolt. And going from kilovolt to volt, we multiply by 1,000, from volt to millivolt by 1,000, and the other way we divide by 1,000. And the SI unit of the voltage is the volt. Its symbol is uppercase V. Okay, now how can I measure this voltage? I know there is a voltage and I know the unit of this voltage, but how can I know the value of this voltage? I can measure it using, remember this device? It is called the multimeter. Okay, and we used it as an ammeter before. Now, we're not going to use it as an ammeter. We're going to use it as a voltmeter. Okay, so this device is called a voltmeter. It is an electric device that measures the voltage. Okay, so a voltmeter, it has two terminals like an ammeter. It has the positive terminal, which is the V terminal, and it has the negative terminal, which is the COM terminal. So now it has a V and a COM. Okay, COM is short for common. Now, if I want to symbolize it, if I want to schematize an electric circuit and use the symbol of a voltmeter, how it would look like? Just, it is really close to an ammeter, but instead of the A, we have a V. So a circle with a V, and then it has two terminals. The positive is the V, and the negative is the COM. Okay, so now that we know that a voltmeter measures the voltage, how can I connect it in a circle? You guys remember in the case of an ammeter, when we wanted to measure the current flowing through the circuit, which goes from the positive pole to the negative pole. Okay, all we needed to do was to cut the circuit and put the ammeter in the circuit in series with the rest of the components so that they all make one loop. And yeah, that's it. We can then measure the current flowing through the circuit. But now I'm talking about the voltage. The voltage, it is different. It is the voltage across an electrical component. And I could be finding the voltage across the lamp. I could be finding the voltage across the battery, voltage across the switch, voltage across a connecting wire, which we will do in the upcoming slides. So yeah, how can I connect it? Okay, first thing I will tell you that the circuit will remain the same. It will not change. I will not open the circuit. It will remain as it is. What I will do is that the voltmeter will be connected in parallel to a certain electrical device. The voltmeter would measure the voltage across that device. So let's say I want to measure the voltage across the lamp. I know that the battery is giving out a voltage, all right, to the lamp. So I want to see how much voltage is given to the lamp. So yeah, let's see how can we connect it in parallel. First thing we need to do, first of all, you can look at the voltmeter. For a proper connection, as before, the V terminal or the plus terminal must be connected to the positive side, to the same side as the positive pole, and the COM to the same side as the negative pole. So this one is the V to the same side as the positive, the COM is to the same side as the negative, and the voltmeter will give an answer, 4.41 volt. Okay guys, this is how we connected. This is what we mean by parallel. It means I'm adding another loop with the voltmeter. Okay, it means you're adding a loop. This is what we mean by parallel. But of course, if I want to draw it in, if I want to schematize it, it will look something like this. This is the voltmeter connected across the lamp. It measures the voltage across the lamp. This is its COM terminal and this is its V terminal. Okay, now how about the calibers that I have here? I will not explain them in details as last time, as I did with the ammeter, but it is the same thing basically. We need to start with the biggest caliber. Each caliber is the maximum value that the voltmeter can read. So if you simply chose a wrong caliber, you chose, let's say, a 2, and you're reading a 4.41, then the voltmeter will not give you a correct value, and if you keep it for long, it might get damaged. Okay, this is why it's better we always start with the biggest caliber because we don't know, how much the voltage we're actually measuring, and then we go to a smaller one until we reach the most precise caliber there is. Okay, so yeah, it is usually the caliber that is closest to the value, okay, but of course greater than it. Okay, so now what if I connected the V terminal to the same side as the negative pole, just like that, and the COM terminal to the same side as the positive pole? What will the voltmeter give me? You guys remember the case with the ammeter? So yeah, if I did this, then the voltmeter will give me a negative value, and that's it. It will not get damaged, okay? So to correct the indication, I can simply reverse the connections of the voltmeter, which means the V must be connected here and the COM here, or I can simply reverse the connections of the battery. So, yeah, this is the note. Okay, so now we're going to find out what is the voltage across the battery, and then later on across a closed switch, across an open switch, across the lamp, across a connecting wire. Okay, starting with the battery, voltage across a battery. It means I need to connect both of the terminals of the voltmeter to the terminals of the battery. As we previously stated, the positive terminal of the voltmeter must be connected to the positive pole and the negative to the negative pole, just like that. Now, this is the case where K is open. Okay, so there is no electrical current flowing through this circuit. What will be the voltage across the battery? We know that the battery is the generator. Okay, it is a voltage source. So to be honest, it doesn't matter if the switch is open or closed. There will always be a voltage across its terminals because it's a battery, it's a voltage source. So in case where the switch is open or closed, I'm gonna get a voltage across the battery. Of course, I might get a different value. Okay, this is just like an example. But the point is that there is always voltage across the terminals of a battery, whether placed in a circuit or isolated. Even if I took a battery like this, okay, and I measure the voltage across its terminals, I would still get, a number. Now the voltage across a lamp, a motor, basically it's like a receiver, an electric device that needs a generator in a circuit so that it glows, so that it works. It needs electricity. It does not generate electricity. So yeah, let's work with the case of a lamp here. So we have two circuits, an open circuit and a closed circuit. So in an open circuit, of course, there is no electrical current flowing through the circuit, so the lamp doesn't glow. So if I want to connect the voltmeter across the terminals of a lamp, I would get a 0 because when the lamp doesn't glow, it means there is no electrical current flowing through it, which means there is no voltage across it. Okay, guys? And the second case where the switch is closed, the lamp glows, and the voltage across the lamp, it has a certain value. Now, this is, of course, is an example. It could be anything else, but yes, it has a certain value. Okay, guys? And it is the same voltage, of course, in this case as the battery because the battery is giving, okay, it is giving this voltage to the lamp. So yeah, the voltage across the terminals of an unlit lamp in an open circuit is 0. The voltage across the terminals of a lit lamp is not 0. Now the voltage across a connecting wire in the case of an open switch and a closed switch. The voltage across a connecting wire, guys, it is always 0. It doesn't matter if the switch is open or closed, it is always 0. It's a wire, okay? So yeah, the voltage across the terminals of a connecting wire is 0, whether the circuit is open or closed. And now the last case of a switch. I'm gonna try to find the voltage across an open switch and the voltage across a closed switch. Now, the case of a closed switch, doesn't it look like a wire? Like when it's closed, it looks like a wire, and the voltage across a wire is 0. So I think in this case, the voltage is going to be 0. But let's see what I will get with the open switch. So in the case of a closed switch, we just said it looks like a wire, so it's going to be 0. But in the case of an open switch, okay, and you guys have noticed that I am connecting the V terminal, the positive terminal, to the same side as the positive pole, and negative, same side as the negative, okay? In all the cases, I'm just connecting it properly. So yeah, in the case of an open switch, you guys will see that we have a voltage across an open switch, and not any voltage. This voltage is equal to the voltage across the battery. This is interesting. And that is it. We're done with this week's lecture and we're done with the chapter. I hope you guys found it interesting. Study well, take care, and I'll see you in the live session. Bye bye.